Hello everyone. My name is Dharamveer Kumar. I'm a PhD candidate at IIT Bombay, and today we will be solving assignment 1 and assignment 2. Since the solution is already shared, the exam is done, so I'll just talk about it. And if you have any questions about assignment 3, you can ask me. You can also drop in your comments. And whenever you have a question, just type it in. Okay, I'll be really happy to answer that. Okay, so we'll solve. Just let me check once. That's the problem. That's it. Yeah. So there are a lot of problems in this. I'll try to solve them. Like, I will try to solve as many as possible. Hopefully, all of them, and we'll see how it goes. So, yeah. Assignment 1. Let's see what is the question. And just type whenever you have a issue. If you're not able to understand, just type. Okay. It's a true and false question. Consider any two non-empty sets. That's right. Okay. And subsets AB of X. Okay. For any function f from x to y, what do you think? What did you write? You can type it in, true or false, whatever. Okay. So I'll start with where this is like, why whenever you mention a set, right, you have to like mention if it's non-empty or not. So like, let's say someone says that find a set where some properties of a function holds. Okay, and you find that set. Let's say you have to use it in some way, you have to minimize something or something like that. You need to first, like, that is the first step to show is that the set is non-empty. Whenever you are like, you're told to find a set, you have to first show that either the property satisfies for an empty set, or whenever you're defining a set, it's a very first step, and sometimes non-trivial step. It's not always trivial. People forget that, and the most important thing sometimes is to show that a set is non-empty. Okay, so over here it's given, but sometimes you have to so like, just keep in mind that given a set, always just for millisecond always think that, okay, like, if this set is empty or not. Okay, when you are claiming that, okay, there exists a set where something like this happens, is it empty or not? For instance, yeah, so if I define a function, right, from R to R, and f of x is 1, right, and if I say f is equal to 2 on A equal to this statement is true or false. Talking about this f right now, like let's call it g for convenience. Let's call it g. Is the statement true or false? This is a true statement, but this A is non-empty. Non-empty set, anything can happen. Like let's say if I write g of phi, how do you define it? Do you know what it is? Like any understanding of this? Okay. So like right over here, we are writing f of a, f of b. What does it mean? It's a set, right? So for real number, there must be a set. So do you understand that a is phi? Given g, a is phi. Is that clear? Right. So how do you write g of phi? Can you define it? What is that set? Right. So if g is not given to you, whenever you see this statement, unless a is phi, this statement is always true. But it turns out that over here a is the set is phi, so that's why this statement is true for this false for this particular g. You cannot write g is equal to 2 because that set itself is empty. That's why it's important to understand we are given non-empty sets, but always check what is empty set or not. It's a mapping of empty set, and any function whenever you're mapping, by default you understand that it's going to empty set. Okay? Now, this statement, okay? First try to understand or like visualize what this is. So there are two subsets. So there is like x, there is y, there is an intersection as well, right? Between a and b. And they are saying that whenever this maps, we have this property. So let's do one thing. We can do this, something like that. So f of a will be at some place a little smaller. So we have to look at f of a intersection b. And then there is, this is f of a, and then there is f of b, and there is also an intersection. What we are saying is that this is only mapping over here. What do you think? True, false? Think. See, I want you to think. False. Can you give a counter example? Like, why are you thinking that? Just any counter example will do. For instance, when A intersection B is not there, it's empty, right? And then they both could be, like one element could be the same. So f of A intersection B, this is phi, which is phi, and f of A intersection f of B will at least contain them. So this will not be equal to phi. Can I generalize this? Let's say x contains x1 and x2. Okay? Let A be x1, it's a set, and B be x2. The intersection fails, there is no intersection. So f of A intersection B is phi. F of A will be something, just call it 1. Let y be fixed value. So f of A would be just this y set, and f of B would again be just y set. So f of A intersection f of B would be just y set. These are not same. But what do we see from here? There's an inclusion. From here, just for this case, is this true in general? Just a little note, there is always some kind of inclusion like this. So you can take an example and solve, it will be true. If you can show this, it is in general true. It's not a math, just a trick to remember. So this is in fact true. Same goes for union. There is some sort of inclusion one way or the other. Just verify with one, it works for them. It's a trick, it's not maths. So you have something over here. So see, it was a very simple problem, right? Very simple problem, nothing to, like, you can easily give one example or two example like this. But now the question is, can you find category of A, B, F such that equality holds? This is your, you can solve it, you can check with me, you can solve it independently, Google it, but there exists definitely. I'm not going to tell you, for some it will be redundant, it would work for all F or all A, some sort of thing, but yeah. So you need to find when this equality holds, and this is a very nice, good exercise on set theory. Things like this, it's naive set theory, but still good exam, good exercise. This is how you have to study, not just okay, we're solving something, you're done, it's MCQ question. You have to think about it. The polynomial problem I will do at the end. Probably in the next class. I'll see if I have time. I'll do this now. So this is how you write a sequence ideally. You're saying it's a set basically. B, two sequences. Okay? Now define two other. Easily definable is max of x and yn, and then you define a small mn, which is min of for all and then z plus. Now suppose we are assuming that limit n tends to infinity this and this exists. We don't know what it is, but let's say we know the existence question, right? For every epsilon, the delta definition. For every epsilon, there exists a capital N, such that for all small n greater than that capital N, the mod is bounded by epsilon. So then there is a question. It's a multiple choice questions, right? Sorry. So the question is, so I'm just changing the question, you have to like define it straightforward, does this and this exist? Okay, just think like this. Okay, it's x1, x2, blah 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 blah, y1, y2, blah blah. So whatever it is in, like, whichever is bigger in x1, x2, the bigger value bigger, and the second one smaller. Same over here, the bigger from x2 and y2, and then the smaller. Same for each one of them. You can always do this. This is also a sequence, this is also a sequence. They're saying that this and this exists. What does it mean? So let's say we call the name of this limit as x. Okay. So what does it mean? So we'll write that some epsilon 1 and epsilon 2. For epsilon 1 greater than 0, here exists n1 in natural numbers such that for all n greater than n1, what happens? Xn minus x. Same thing we can do for y. Now note one thing, that this any mn we have this property and we have so let's say x1 is bigger one, so m1 capital M1 will be equal to, so we can always write less than equal to, and same goes over here. One of them is an equality, one of them is a strict inequality or maybe equality as well when both xk and yk are same. Okay, so we can always write this. This is something that we have. Okay, so now there is n1 and n1, or in this case whenever you have like 2, choose the bigger one of them, so that this condition holds for everything, right? So for all n greater than maximum of n1 and n2, okay, so you have to, for all n there is like, let's say n1 without loss in generality, let's say n2 is greater than this. So for whichever is greater, we are finding this small n greater than this. Okay, so this both are valid for this n. Okay, so we just add them up. What should we do? What do you think? One step is we can open this up. And then yn is now what? All we have is this. Tell me, any hints? Tell me. Just try to think with it. There is a very simple answer to this, but do you think we can work with this? because if we substitute only this, so we get something about mn in x, nothing else. We need bounds on both sides, right? We need mod of this. We don't get anything. We need, but we know that there are only two values, so we need more stronger conditions on this. This is there, nothing can be changed over here. All we can do is sum or multiply or these two equations. We don't think we are getting anywhere. So that means we need more. This is a very weaker condition. We need more stronger condition than this capital Mn and small mn. This is how you proceed. We can write. Can we write mn, capital Mn in terms of xn and yn? If we use something like this, plus, so whichever is bigger, that will be positive over here. So let's say xn is bigger, both cases we will see. So xn plus yn plus xn minus yn, yn cancels, it will just be xn. Same goes if yn is greater, this will be yn minus xn, xn plus yn, it will be yn. So whichever is bigger, it's giving us. For the other side, the smaller one, same thing it does. It will cancel the one and give you the minimum. So let's say xn is bigger, let's say, so it's minus xn plus yn, so it's giving yn. This is more concrete. Okay, this is much more stronger than this. This is giving a equality rather than there is an inequality over. Okay, so what we can do from here now, we can add them up definitely. What else? Let's do it a hard way, and then I will tell you a more easier trick about taking the limits. Basically, when you say fn or yn plus zn, if both, always remember, if both the limit exists, then limit xn is equal to limit yn plus limit zn. If they both exist, only if they both exist. Okay. And another thing is, this I told in last class as well. This is a sequence. This is same as. Later you will see it is true for all continuous functions. If there is a sequence, and this is a continuous function, you can actually take if xn converges to x. Okay, you can take the limit, true, but you need to keep these things in mind. Okay, can we prove this? Let's prove this. So if fn plus gn, so no, first let's prove here in this example only, we have yn, right? Now I'll tell you two things. For lambda in real number, limit of lambda xn is lambda x. Case 1, lambda equal to 0, limit of 0 is equal to 0. Lambda not equal to 0. So what will you do in this case? You want to check this, right? Lambda is something there. So mod lambda xn minus x. We have xn minus x bounded by epsilon, right? This is equal to this. This is bounded by epsilon into mod lambda, right? Just name this epsilon. So for every given epsilon, you choose epsilon 1 is equal to, put it over here, you get an n1. For that, this is true. So we have done this case, right? What about sum? Since these two exist, we just sum it up. Choose epsilon 1. This implies so we have proved these things. With the help of these two, we can do anything like this. Lambda xn plus beta yn is equal to lambda x plus beta y. It's linear. Okay? So since over here, so now what is remaining? This mod thing. Mod is very simple. Mod xn so what I want to show, mod xn converges to mod x, right? So what we can write as mod xn minus mod x mod of this, and somehow we have to show xn minus x. So mod xn is greater than xn mod x so if I do minus over here, just keep it x. Oh, sorry. Sign changes. My bad. Yeah, think like this. Yeah, sorry. You're right. Do you know this inequality? This is called triangle inequality. You take mod x over here, mod a plus b, mod this is basically, this comes from this implies it's greater than both positive and negative, right? These are just negative of each other. So this is there. So if this is bounded by epsilon 1, choose epsilon is equal to epsilon 1 and you get this. This is how you do the mod. And now you can take the limit. If you take the limit, so first you need to show that limit of these both exists. You can write it as xn plus yn by 2 plus xn minus mod yn by 2. So does limit of this exist? Using this. Does limit of this exist? First use this. Limit of this exists, the top, then use the lambda thing. Both the limit exists. Now you can take the limit. So that implies this m, if that limit is x plus y, x minus y by 2. The small m is, you can also write it as maximum of xy and minimum of xy. So now you can say, you can also say max of x and yn whenever you take the limit. This is nothing but max of xy. You can take a limit inside max. This is what this question proves. Nothing else is assumed, only that this limit exists. Same goes for min. Now let, again there are two sequences such that then they're asking, is it possible that always that the limit are equal? Is it possible that the sign is reversed when we take the limit? Or will the sign remain? Basically, when you're taking the limit, does the sign remains if the limit exists? Okay? So should I write options? Okay, I'll write options once. Which of, okay, let me ask you one thing, change a question. which of them is possible? Multiple options can be correct. It's not a single answering question. Which of them are possible? And B is also possible when xn equal to yn. So this is again possible. This is always true. This is impossible. So A and B are possible. So this was like in JEE times you used to give HC Verma questions where there were like multiple options which could be correct. So it was like that. Just 1 second. Think about this, how to do this. Oh, yeah. So let's do this. Like previous question, just assume limit. I'm not writing n goes to infinity every time, right? I'm just writing limit. Understand this as good as limit n goes to infinity, okay? You're given two things, okay? So then again we can choose epsilon 1 and epsilon 2. Right? So this is like xn minus 1 divided by epsilon 1 yn minus y epsilon 2, right? So for every epsilon 1 epsilon 2 greater than 0 there exists n natural number such that for all n, so whenever something like this happens, I've already told you, you can merge, you can take this max of n1 and 2, you can do this separately, but the whole both the statements, if you write something like this, both the statements are valid. Okay, this is always an ideal case to do. Now what? Do this. We can open it up and see what we can do. We have this condition, right? So what we can do is we can get a condition. So xn is greater than equal to yn. Yn is, we know, 100 by So if we have to show that x is, this is wrong, we have to show this, right? So this fails. So in first class I told you about contradiction, right? So let's assume, where it is star, and we'll show by contradiction. Let's assume x is greater than y. This implies that x minus y is greater than 0. We have assumed this, right? And from here we have this, which implies that y minus epsilon 2 x plus epsilon 1 for every epsilon and epsilon 2 greater than 0. Let's use epsilon 1 equal to epsilon 2. So this implies y minus x bounded by is equal to some epsilon. Okay, you don't know what that is. Now sorry, my bad. So yn is greater than xn. Sorry, my bad. Right, and then this is something like this, epsilon by 2. So this will be nothing but epsilon for any epsilon greater than 0. What can you say from here? If I say f is a real number, m is a real number and m is less than epsilon for every epsilon greater than 0. What can we say about m from here? A very classic question, just think about this. This question. You are going to use this so many times. Guys, come on, it's a very simple question. M belongs to some real number. M is less than equal to epsilon for every epsilon greater than 0. What can you say about m from here? You have to get, sorry, m is less than equal to 0. And you show this by the same technique that I'm going to use here. We have assumed that x minus y is greater than equal to 0. This is true for any epsilon greater than 0. Choose or rather just let it be. What does this imply? If I choose epsilon to be x minus y over 2, this implies this is positive. I can cut it out, half greater than, which is a contradiction. So x cannot be greater than y. But this is the same thing, same logic applies over here. Whenever m is bounded by epsilon for any epsilon greater than 0, you can do this and you can get this. Like by contradiction, first assume m greater than 0 and then you can show that m cannot be greater than 0. Yes. Okay, I'll take a break, 2 minutes. Okay, so we are back. Are you guys there? Okay, Sushant. Oh, just okay. So next question. Question number 4. So this question is, yeah, this is a new type of questions where you have to like think. I think it comes in all the competitive exams, that is the statement true and the converse is false or both are true, stuff like that. Okay, so this is the statement. So it's written like this: P so you say it like, consider the following statement, and whenever you want to talk about the statement, you'll refer from P what you're going to say. So for any real sequence xn and L in R, this is the crux: if xn converges to x, then so there are 4 options. P is true, converse is true, P is true, but converse is false. Now P is false, but converse is true, and the fourth, P and its converse is false. Both are false. Converse means, so you can write it in two. The statement is xn converges to x implies mod xn converges to mod n. Another thing is, this is the statement, this is the converse. So we have done this statement just in the previous question. So the statement is definitely true. These two options. Now we have to show that if the converse is false or true, right? How can we get this? Can we think of counter example? A very simple counter example is 1 minus 1, 1 minus 1, 1 minus 1. This could be this xn sequence, right? If we do mod xn, it is nothing but 1, 1, 1, 1, 1. Okay, so this sequence, this 1, 1, 1 converges, but this diverges. So mod xn is converging and xn is not converging. Let me pose a new question. Let xn converge and let xn converge. What will be so mod xn is converging to some value. What will xn converge? I'm saying that xn converges to something, right? What are the possibilities? Is there one answer? Are there two answers? It could only be plus minus mod n. That's it. Good. Mod L basically, not L is not positive, I'm not saying, but yeah, plus minus model. Very good. Because let's say limit xn converges to some y, or like let's say converges to x. This implies that limit of mod xn converges to mod x, and this is already given, which is mod l. That implies x is equal to plus minus mod l. Mod x is equal to l, so x could only be this, nothing else. Okay. You should always think about new questions. When you start to think about new questions, then like when you start to create your own questions, small questions, then you have gotten the hang of real analysis. Okay, till then you're just learning. Again, same set of options, Similar question. So if every even number and odd number converges to the same thing, the function also converges, and vice versa. So vice versa is it true? For converse, I will tell you a more general theorem. So you will think that, okay, it's very obvious, the converse. What about the statement itself? So I'll show this to you, how it's done. How do you say? The statement, and then for converse I will tell you something more general. Okay, so let's say again, for epsilon greater than 0 there exists n1 in natural number such that for all n there will exist some natural number such that for all n greater than this n1 Is this clear? Even if it's 2 and it doesn't matter, this statement is true. There exists some number. Okay. So for example, if I write x1, x2, x3, blah 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 blah, x4. So this sequence is nothing but x2, x4, x6 and so on. This is x2n, right? And this sequence is converging. So there is some n after which this is happening. Okay? There is some number which is a multiple of 2, like maybe x100 or something like that, after which for a given epsilon, so let's say I choose some epsilon after x100, this is true. So I can write, so n1 is just 50. Okay. Similarly, x2n plus 1. Oh, sandwich theorem. How? Can you explain? How are we going to sandwich? It's totally okay to do that. Yeah, so that's okay. Similarly, for epsilon 2 greater than 0, there exists some n2. You have to like focus a bit to think about this, and then you'll get this some epsilon 2. Always start with epsilon 1, epsilon 2, that's okay, right? So you have this. Now take this n to be 2 times maximum of n1 and n2. So let's say there was some n1 without loss in generality. Let's say n2 is greater than n1, and then so just this is the maximum. After this, if I do put 2 times of this, sorry, 2n1 and 2n2, right? That is n. After this, all the odd numbers and all the even numbers have the same property. So that means and choose epsilon is equal to, sorry, epsilon 1, epsilon 2 is equal to epsilon. So for every epsilon greater than 0, for all n greater than this n, this is true. This is how you find n. Basically, you have to find n for a given epsilon. You have to find n. This is how you find n. So the statement is true. Now you'll learn later, but I'm just giving his simple explanation of something called a subsequence. So if you have I'm not defining it. So n is something that you pick in the same order. Not defining it, just giving you an intuition. So you start with x2. You cannot go back again x1. You can pick something later, x5, x9, x100. There is no order, x1000, x1001. Again you can go back. Something like that. Something that you take out in the same order. Again, it has to be a sequence going to infinity. So if this is xn, so if xn converges to x, then we typically write it, I'm writing it as yn, we typically write it as xnj. xnj also converges to x. So if I say this, the converse is also true. Both are the same thing. Both are the subsequence, right? We're picking 2, 4, 6, 8 in that order, then 1, 3, 5, 7 in that order. Both are subsequence. Since x2 and n, x2n plus 1 are
x2n plus 1.
Hello? Can you hear me? Please let me know if you can hear me. Yeah. So our subsequence, hence converse is also true. याद है हमें. If there is a question, you can ask. Okay. So how do we prove this? I'll prove this. So you already have for some epsilon 1 greater than 0, there exists an natural number such that for all n greater than n, but for a subsequence, this is always true. Because in a subsequence, basically what you do is so with a given j, nj is what you're picking is something like this. You're picking always like next numbers. Like for first, it will always be 1 or greater than 1. For the second element will always be greater than 2. The third element will always be greater than 3, and so on. So if there is a sequence and it converges, so for some epsilon, let's say you get this n, and after this everything is going to converge, right? Like after that this is true. So now whenever you are taking subsequence, at this place, at nth place, you will always have something, n plus something, always a term after that. And for these terms, and then again it will be nj plus 1 or something like that, some plus 2 or whatever. It will always be greater than those numbers. So for all these numbers, this still is true. So I'm not writing this. Basically, this implies xnj minus x, because this contain all the elements of subsequence. Okay, you'll I think do this later, but I just told you right now. Since we are on this question itself, let's do question 7. It's a true or false question. I hope you know what a Cauchy sequence is. So if xn is Cauchy, in case you don't remember, in real numbers, Cauchy implies convergence. If xn is Cauchy, I don't know, this question is a bit redundant. Right now I don't think you have you learned this? That Cauchy implies conversion? Anyone, can you tell me? I'm not sure, not seen the syllabus. So basically you don't need this as well. This is a real sequence. For real sequence, it's not always true. For real sequences. So for real sequence, Cauchy is convergence, so this is definitely true. You don't need this. I don't know why it is given, but yeah. Moving on. Question 8. I'll solve this later. Oh, yeah. I'm not understanding why this is given. Yeah. So again a true false question. Can you tell me why? This is basically a harmonic sum. Yeah. There are multiple ways to solve this. I'll do it with one of the methods, but there are multiple methods to solve this. Do you guys know any method? Yeah, I know it's harmonic series, but how do you show that it's divergent? One of the methods that I use is like something called the sandwich theorem you were talking about, right? So you have this is 1 over x give two methods for this. At 1, this is 1, right? 2, this is 1 by 2. So if I consider these boxes, right, this is 1, this is 1 by 2, this is 1 by 3. So basically this xn, I'm just summing up, is less than from 1 second. Yeah. I have to find out about the upper bound. So this is 1, this is 1, 2 its half, so this is 2. Still n plus 1. So this xn is greater than 1 over x from 1 to n plus 1. Do you get this? Please let me know if you don't get this, right? I'm just doing this triangles and this area under this curve is obviously bounded by xn. Can you integrate 1 over x? This is nothing but this implies ln of n plus 1 bounded by xn. If you take limit on both the sides, what happens? This goes to infinity. Okay? This is method 1. If you've seen this, you can do this like multiple times if you have like a good idea about what something like this mimics a function. Let me know if it's not clear. I've given this, right? If if it mimics a function, this is always a good idea. Draw these triangles and find this bound. It's bounded by something lower which is going to infinity, which you can evaluate, like over here. Because you don't know any method to sum this up, right? Like if you do, there's like no very good formula for like harmonics or like a very simple method. Okay, another thing that we can do is, I've taught you the sequence, right? So if I'm not sure what's happening, just 1 second. Yeah. Yeah. So this was method 1. Another method is, I told you, right? If xn converges, that implies every subsequence converges. So if you show that one of the subsequence is not converging, that means xn doesn't converge. Okay, there could be a sequence where some subsequence converges, but at least if one doesn't converge, the sequence doesn't converge. For example, 1 minus 1, 1 minus 1, 1 minus. Whenever there is a question of subsequence, I always consider this. So 1, 1, 1, 1. This is a subsequence converging to 1. Minus 1, minus 1, minus 1. This is subsequence. These two subsequence are converging, but this is not enough. Okay, in the question that we had earlier, x2n and x2n plus 1 were both converging to the same thing. They are not converging over here. These are odd and even. They are converging to different numbers. The sequence does not converge. Okay, so these are convergent subsequence, but all the one subsequence of a sequence is a subsequence of itself. This is not convergent. In fact, any alternating sequence is not convergent, like a not equal to b, ab, ab, ab is not convergent. Okay, so this is not convergent, but the some subsequences are convergent. So xn converges when every subsequence, that implies that every subsequence converges. There is an alternate example, that if every subsequence converges, if that implies xn converges. It's a very simple thing, because if every subsequence converges, a sequence is a subsequence of itself, so that converges, so obviously xn converges. This is something that you have to read later. I'm just wasting a little bit of your time, but yeah, let's do this. I'll just show you that. So in this type of questions, you can also find one subsequence such that it's not convergent. The limit should be, converges with same limit, obviously. One second, let me see. Yeah. Okay. So now this we have to do. Right. So now just do x2 over n. In this case, just do x2. That means j from 1 to 2n of 1 over j. Right? So this can be written as so like let's say from k is equal to 1, this is one second. So when k is equal to 1, 1 minus 1 0, this is 2. So starting from j equal to 2 to 2 plus j equal to 2 just expanding this. Finishes at 2 square, starting at 2 square plus 1, going to so on, right? Till you go to, always it's good to expand till 2n. You are covering everything. So from 1 to 1 over 2n. So in this case, just using one of the thing that this j is, whenever you are summing, is less than 2k. That implies 1 over 2k so j is less than 1 over 2k. So 1 over j is greater than 1 over 2k. Summing over positives. Right? What is this? Anyone? think about this. Pick any k, right? And you're just doing this sum. There is no j in this. So all you have to do is this. What do you have to do? If you are given sum over j equal to sum alpha to beta, and there is no j over here, right? Some function of alpha beta. How do you sum this? Anyone? It's a very simple thing I'm asking. Alpha and beta are natural numbers. How do you sum this? How do you sum this? What is this? Can you tell me? Number in terms of alpha beta. What is this? Very simple example. J equal to 5 to 9. What is this? This is beta minus alpha plus 1. So this is nothing but alpha beta into beta minus alpha plus 1. This plus 1 is important. Okay? Please focus on this. So whenever you do this, over here, this equal to, I'm not taking inequality. There's no sum over j. So this whole thing is nothing but 1 over 2k is out into 2k minus 2k minus 1 minus 1 plus 1. This whole thing is the over alpha over here. So minus 1 gets cancelled. This is nothing but 1 plus. You can take divide over here. This is 1 minus 1 over 2, which is 1 plus 1 over 2 n minus 1 plus 1, again n by 2 plus 1. Yeah, 5. It won't be 4, it's 5. 9 minus 5 plus 1. Okay, so what we have shown is x2n is greater than equal to 1 plus n by 2. This is unbounded or convergent. That implies xn is non-convergent. Okay. Is this clear? You multiple techniques to solve this. Let's come back over here. The Cauchy. I don't know why it's given. I'll play along. So if xn is Cauchy, probably to give, like if it's more than a real sequence or a complete space. We are not looking at complete space, I think. Real space is complete space, but yeah, for now let's forget that. So we are saying that xn is Cauchy and x2n is convergent. It's true irrespective of if x2n is convergent or not. Okay, but probably it's a simpler proof. Okay, so let x2n converge to x. Okay, that means for every epsilon. See, I'm not giving epsilon by 2, epsilon by 5, epsilon by 3 and everything, right? That comes later. You can understand it later. Start with epsilon 1. Some epsilon. Because people give you like, okay, for pick epsilon by 2 and everything. That comes by reverse engineering. So always start with epsilon 1. At the end you will get something like this. Whatever you want to prove, let's say if you want to prove from somewhere, you want to prove xn minus x is bounded by epsilon, and you get something like this. So what you do is, because you are picking up epsilon 1, you say epsilon 1 is for an arbitrary epsilon. So always keep this in mind. Whenever someone is giving you a magical number 9 by 5 epsilon or something, it comes from reverse engineering. Okay. Start from some epsilon 1 or epsilon 2 or something like that, and that at the end you do all the reverse engineering. Okay. So for epsilon greater than 0, there exists some n1 such that for all n greater than n1, x2n minus x is bounded by epsilon 1 okay. What do you know further? There is Cauchy. So again for epsilon such that for all n greater than this interval, so now again you take n to be max of n1 n2, you take it twice. Okay, and what do you get? xn minus a is bounded by and this is bounded by epsilon 1 from this Cauchy thing, epsilon 2, and this is bounded by x basically, sorry. this is bounded by epsilon 1. So you have to take epsilon, this has to be epsilon, so pick epsilon 1 is equal to epsilon by 2. Yeah, probably for the simpler proof, this was given. Do you guys know the proof from Cauchy to convergence? So then someone told me you have done this, right? Anyone? This is a Cauchy sequence. From here, how do you show that it converges? One second. Probably you will do it in later class. So how about the converse? I think it's there in the later class when we study boundedness and everything. After that every bounded sequence is a convergent subsequence and stuff like that. So basically you can do this with any, so you have to show that so basically when you're doing this, it doesn't have to x to n, any convergence. So basically, so if given a Cauchy and any convergent subsequence, okay, they're not using anywhere x to n particularly. So any convergent subsequence. So what you show is, you start with Cauchy, you show that a sequence is bounded, then from there you show that every bounded sequence has a convergent subsequence, then again Cauchy and this convergent subsequence, and that's how you show convergence. Okay, right now you don't have to do this. I saw it, it's later in your syllabus, but you can do this. Every convergent sequence is Cauchy. That is true everywhere, irrespective of real numbers, metric spaces, wherever you go. Okay, so if this we will do later. So now for every epsilon 1 greater than 0, right? So now how do you do this? So for all nmn greater than n1, this is there, this is again bounded by it's the same epsilon actually, because for a given epsilon you can do this. So that means this is there, Now choose epsilon 1 equal to by 2. That means it is simple. The converse is simple. Every convergent sequence is Cauchy. But every Cauchy is convergent. I told you the steps. If you want to do it right now, you can do it. But it's actually for the later stages. Okay? Yeah. So I think we have done all the questions in assignment 1. Do you guys have any doubts of what we studied today in assignment 3 or any other doubts that you have? In last class I was telling someone about limb sup and limb in. So I really like that someone asked the question. You guys should interact a bit. Compact set. Okay. Yeah. Just 1 second. Yeah. Give me. On. So if you have seen the YouTube videos, okay, they are helpful. Okay. Thank you. Okay. So what is a compact set? Multiple ways to understand it. First of all, where are we looking at compact set? Okay. Do you want to just know in context of real numbers or in general? Karthikeyan? Real numbers. Okay. So for real numbers, there is a very simple definition. So any subset A of real number, again real number cannot be compact, so we are taking a proper subset. This is how you write it. Subset of R is compact, and so whenever there is if and only if, that could be the definition. The subset is closed and bounded. Do you understand what bounded means? Simple. Can you tell me? If this is compact. This is not bounded, right? No, this is not open, this is closed. Why this is closed? Because this is open and this is closed. Closed but not bounded. Bounded but not closed. Both are non-compact. 2, 3 union 700. This is compact. They are closed and bounded. Yeah, very good, Sushant. But this was not upper bounded. Is this clear? So you have to see, I've told you, right, how to find close. Take the complement, if that's open, then the set is closed. Open, you know how to find. You have to take a, for each point, there should be a tiny interval contained in itself. Open interval. Yeah. So this is how you find compacts. In fact, this is true for every Rn. After Rn, it is not true. Like in R2, R3 space, Rn space also this is true. If it's closed and bounded, like a closed ball, a sphere is compact. But in general, for higher dimension space, that is not true. Okay, any more doubts? How about this? Is this compact? Anyone? Going up to infinity. Is this compact? Karthikeyan? Yeah, because it's not bounded, right? Yeah, good. Okay, so we are done for today. In next class, I will talk about this polynomial problem that was in assignment 1, and then I'll also do assignment 2, probably 3, and we'll see how it goes, right? Are you guys enjoying it? Learning a bit? Yeah. Okay, yeah, thank you. So yeah, that's it for the meeting, and